Welcome to RR Max channel. We are doing reduction formulae. This is episode 7. We shall continue and find out formulae for tan power nx, cot power nx, secant power nx and cosecant power nx. I will start with In is equal to integral of tan to the power of n x dx where n belongs to a positive integer. So we'll find out a formula for this. Here tan to the power of nx, you split it as tan to the power of n minus 2x into tan square x dx. And this tan square x is rewritten as secant square x minus 1. So you now have two different integrals. First integral will be integral of tan to the power of n minus 2x into secant square x dx minus integral of tan to the power of n minus 2x dx. Now the first integral, you can make a substitution. Tan x is equal to t and then you get secant square x dx is equal to dt. So this will actually be integral of t to the power of n minus 2 dt minus integral of tan to the power of n minus 2x can be rewritten as minus I n minus 2. Now this if you integrate, you will get t to the power of n minus 1 divided by n minus 1 minus I n minus 2. So that you replace your t, you get tan to the power of n minus 1 x by n minus 1 minus I n minus 2. When n is even, the last integral will be I naught, which is integral dx is equal to x. And when n is odd, last integral is I1, which is equal to integral tan x dx, which will be minus log cos x, or you rewrite it as log secant x. So that will be the formula for tan power nx. And now we shall see the formula for cot to the power of nx. Let In is equal to integral cot to the power n x dx. N belongs to positive integers. Here also we split it in the same manner. So In is equal to cot to the power of n minus 2x into cot square x dx. This cot square x is being replaced by cosecant square x minus 1. Now split it as two integrals. You get integral cot to the power of n minus 2x cosecant square x dx minus integral of cot to the power of n minus 2x dx. The first case you substitute cot x as t, then you get minus cosecant square x dx is equal to dt. So the first case becomes t to the integral of t to the power of n minus 2 into minus dt, and minus the second integral becomes I n minus 2. And so when you integrate this one, you get minus of t to the power of n minus 1 by n minus 1 minus I n minus 2. And you substitute your t back to get minus cot to the power of n minus 1 by n minus 1 minus I n minus 2. The last integral when n is even will be I naught is equal to integral of dx, which is x. And when n is odd, you will have I1, which is integral of cot x dx, which is log sin x. So these are formulas for tan power nx and cot power nx. Next we shall see for secant to the power of nx. I again call In is equal to integral of secant to the power of n x dx. N belongs to positive integers. Here also we will split and write In is equal to integral of secant to the power of n minus 2x into secant square x dx. Now we are going to integrate by parts. There I will use u is equal to secant to the power of n minus 2x. That means when you differentiate, du will be n minus 2 into secant to the power of n minus 3 into x into differential of secant x, which is secant x tan x. Now when you club this secant x here, you will get it as n minus 2 into secant to the power of n minus 2x tan x. You will have to add an dx here. So you get dx. And I am taking dv is equal to secant square x dx. On integrating, we get v is equal to tan x. And we will use the formula tan square x is equal to secant square x minus 1. So I am integrating by parts. So that gives me uv minus integral v du. So u is secant to the power of n minus 2x into v is tan x minus integral v du. So v is tan x into du is minus into n minus 2 into secant to the power of n minus 2x tan x dx. So now this tan x into tan x will give you tan square x, and that tan square x will be replaced as secant square x minus 1. So the first integral remains, first part remains as secant to the power of n minus 2x tan x minus n minus 2 comes out, integral of secant to the power of n minus 2x into secant square x minus 1 dx. Now this becomes two integrals. So it reduces to n minus 2 into integral of secant to the power of n x minus integral of secant to the power of n minus 2x dx. So this one can be replaced as in and this one as in minus 2. So now in is equal to secant to the power of n minus 2x tan x minus n minus 2 into in plus n minus 2 into in minus 2. You take this in to your left hand side and take in as common, and that gives you 1 plus n minus 2, which will reduce to n minus 1. So you find out your in finally, where I divide throughout by n minus 1. So I get in is equal to 1 by n minus 1 secant to the power of n minus 2x tan x plus n minus 2 by n minus 1 in minus 2. The last integral when n is even is I naught will give you integral dx, which is x, and when n is odd it will be I1, which is equal to integral of secant x dx. On integration will give you log of secant x plus tan x. The next formula that we see is for cosecant to the power of nx. So in is equal to integral of cosecant to the power of n x dx. N belongs to positive integers. We will follow the same method as we have done above, and you are going to integrate by parts. So you rewrite in as integral of cosecant to the power of n minus 2x into cosecant square x dx, and you take u as cosecant to the power of n minus 2x and dv as cosecant square x dx. So use integration by parts. So you have uv, so cosecant to the power of n minus 2x into integral of cosecant square will give you minus cot x, so that v is minus cot x here. Minus of integral v du. So v is minus cot x, du is I am differentiating here. So that is n minus 2 into cosecant to the power of n minus 3x into differential of cosecant x is minus cosecant x into cot x. So the cosecant x power it becomes n minus 2 as above. Now this cot x into this cot x is cot square, and you replace cot square as cosecant square x minus 1. Now rewrite this as two integrals and you get cosecant to the power of nx minus cosecant to the power of n minus 2x, which can be replaced as in and in minus 2, and bring your in to your left hand side. So in into 1 plus n minus 2 is equal to minus cot x cosecant to the power of n minus 2x plus n minus 2 into in minus 2. Now divide throughout by n minus 1 to give in is equal to minus 1 by n minus 1 cot x cosecant to the power of n minus 2x plus n minus 2 by n minus 1 into in minus 2. Last integral when n is even is I naught, which is integral dx is equal to x, and when n is odd it is I1. Okay, when n is even it is I naught, you got x. For n is odd you have I1, which is integral of cosecant x dx, which will be minus of log of cosecant x plus cot x. Now we have seen these four formulas. I have not used any limits, but if in the problem you have limits, then every time you get your formula in terms of in, you go and substitute your limits, whatever is given to you, and then finally reduce your formula. See you in the next episode. Thank you.